Okay, let's talk about momentum, and then we will talk about linear momentum. Now, a key thing to understand with momentum is a quantity of motion. And it's what governs so many of our sports, car crashes, stuff like that. Now, what it really is the product of mass times velocity. So it's mass times velocity, those two. And we're going to use the letter for linear momentum. We're going to use lowercase p. So small p. Not capital P. Capital P is pressure. And it's equal to m times v. How do you have zero momentum? If you have zero velocity. So when you're at rest, you have zero momentum. You're not moving. Once you get moving, you have some momentum. Now let's take a look at units. We are going to talk about the English system in here, so we'll talk about the English units. We'll also talk about the metric units. The metric units are probably more common if you see momentum in the future. In a physics class or something like that, it's probably going to be the SI units, but I'm going to cover the English units too, simply because I think it's important. It also brings up one of the coolest units of all time. Well, let's take a look at this equation. P is equal to m times v, so therefore mass is nothing more than kilograms. Remember, in this class we deal with big things, so kilograms are more important than grams. Velocity is meters per second, so the units are kilograms times meters divided by seconds. There's no shortcut unit in that. Nothing cancels out. Now, look at the English system. This is really wacky. The English unit for mass is not one you know. It's not one you've probably ever dealt with before. It's actually called a slug. Wow. And you thought they were just squirmy little slimy creatures. No, it's a unit of mass in the English system. Well, velocity would be in feet per second. So that's the units. Nothing cancels out. It's slug times feet per second. Oh my God, that's ugly. I don't know that we'll necessarily even do any math problems with that, but it's important to realize that that's the unit of mass in the English system. Now, why is momentum important? Because momentum governs when things collide, when they hit. So let's go to the game of pool. We have the cue ball. Mass is let's make it 0.1 kilogram. This is the cue ball. It's moving at 10 meters per second when I break. And what I'm going to do is I'm going to hit all the different balls. I'm going to play 9 ball because it's easier to draw. So what I'm going to do now is I'm going to hit these balls in this rack here. And what I'm going to do is I'm going to send them scattered off to around the table. These are not drawn to scale, by the way. Well, my initial momentum is the product of that and that. So my initial momentum is 1 kilogram times meters divided by second. That's how much momentum went into the thing. Well, I'm going to assume over here that the cue ball stops. If the cue ball stops, what's going to happen is it's going to transfer this momentum to all of these balls. So what happens is these balls take off and go different directions. But if I add them all up, you know what I get? 1 kilogram times meters divided by second total. Momentum is conserved. Whatever momentum you start with, you finish with. So, what types of things have big momentum? Big things running fast. LeBron James has a big momentum. He's a big thing, he's running fast. Now, you could possibly have something little with a lot of momentum. A daredevil on a skateboard going at 60 miles an hour would have a great deal of momentum. And we kind of gut feeling understand momentum. Now, we're only talking about linear momentum. We're talking about straight line motion right now. So that key things to remember. Number 1, momentum is conserved. Number 2, rest equals 0 momentum. Number 3, biggest momentum wins in crashes. Think about in soccer, for example, the people you feared the best were usually the fastest, biggest people, because when they hit you, it hurt the most. Or you could have a little person who's extremely fast who could win. So that's the important thing to remember about linear momentum. The other thing is slugs. Slugs are the English unit of mass. I'll later on show you how they came up with the term slug and all that. Most of the stuff you'll see in the future is going to be regular units, kilogram meters per second. There is another unit that means the same thing that we will get to eventually when we talk about momentum more. We're only talking about linear momentum right now, and then of course we'll talk about rotational or angular momentum in the future. Peace.